Right. Can you see my slides? Please let me know if you can't. Slides are okay? Okay. Okay, so we're going to talk today about a new topic, which is exceptions and assertions. It's not difficult at all. Just a quick remark. We have a couple of examples on classes on inheritance, particularly that you will find in the slides, and their scripts are posted on Moodle. If we have time, we can go through them together today, but in principle, you should be able to do them on your own very easily. Yeah? I encourage you to do them. So they built on the example we talked about the last time, which is animal as a superclass, and then you have these other subclasses like cat, rabbit, and person, etc. Yeah, so try to do them, and of course we can discuss them later on if we don't have time today. Okay. So what is exceptions and assertions? So what happens when procedure execution hits an unexpected condition? In other words, right, we've been running programs right now and writing relatively large programs, and it happens that we have certain issues because program expects a certain input and produces a certain output based on this input, and not all it's not always given this input, right? So that's what I mean by an unexpected condition. Something goes wrong in your code because of certain assumptions that you make that do not hold as the program is being executed. So what we get in that case is what is called an exception, to what was expected, to my assumptions. Okay, let's see, for example, what types of exceptions we can get, or examples of this. Trying to access beyond list limits. So in other words, errors. Yeah. So if I have a list like test, which has 3 elements, 1, 7, and 4, and then I say test of 4, trying to refer to the 4th element in this list, I'm going to get an index error. Yeah. Python is going to complain and says, this list has only 3 elements. You're outside the bound of the list. If I try to convert an inappropriate type, let's say, I have a variable called test and I try to cast it into an integer and it's not an integer, that's going to give me a type error. Yeah. Referencing something that doesn't exist. You have a variable A, you're using it in your program, but you never set it to a value in the beginning, initialize it or instantiate it, then it's going to give you an error, and so on. Yeah. For instance, dividing a string by an integer, again, another type error. Yeah, we've looked at these errors firsthand when we were running programs. Yeah, we made some issues, and we just had to stop the program and fix these issues. So types of exceptions, the common ones is syntax error. Basically, Python cannot parse the program. So you're writing code that has some error in its syntax. We have the name error, as we said. So basically, local or global name not found in your program that you're trying to use. Type error, so operand doesn't have the correct type. Value error, so the operand is okay, its type is okay, but its value is illegal. So for instance, you're doing something that a value, for instance, dividing by 0, for instance, that's a value error. Yeah. And IO error, so basically what you typically when you're using files, so you try to open a file that is not found in the system, giving it a wrong path, and so on. Okay, so what to do with exceptions? So far, what we've been doing with exception is the interpreter would stop executing the program and signals an error message. Yeah, so we'll see an example of this in a second. So let's see, here's an example. I have 3 lines of code in this program. I'm defining 2 variables, A and B, and the job is to read 2 numbers from the user. So I'm using the input, yeah, and then I'm casting whatever the user inputs into an integer. And I'm saying print A over B. Okay. What could go wrong here in this code? If I run this code, right, it's going to ask me enter a number, and then I'm going to enter something, and then enter another number, and then I'm going to print A over B. What are the possible things that could go wrong in this program? Any thoughts? B equal to 0. Fadi says B equal to 0. That's correct. So division by 0. That's one possibility. What else? Do I have control what the user inputs? I ask the user to input a number, but can I guarantee that the user is going to input a number? Input a string, exactly as Nasreen is saying. Yeah. So let's try to run it and see what happens if I do this. Okay. So I'm gonna go like here and find a file called exceptions. Okay, let me copy this and run it here. Okay, so here's the code, right? Exactly at the slide. Let's run it. It's going to ask me to enter a number. So what Nasreen was saying is that I could enter a letter instead of a number, right? And that's going to, immediately stop the program from execution, and it says a value error, right? I'm trying to cast S into an integer, and S, of course, is not an integer. Yeah, so that's one possibility. So it stops right after executing line 2. I can do this. Maybe I will enter number the first time. Second time, I don't enter a number. And then again, the code stops executing. So I'm now going to print, of course, A over B because I stopped the execution here and I throw a value. And the third, type of error that could happen is I enter two numbers, but B happens to be a 0. And now I get a 0 division error, yeah, division by 0. So B happens to be 0 and I'm trying to divide 1 by 0. Okay. So this is typically what we've been doing so far. What we're trying to teach you in this module is how do I deal with this in a more professional way. Yeah, so I need to kind of think about what could go wrong in my program as I'm writing it and deal with it appropriately. Yeah, so that when you use any app, real app, right, on your phone or and on your computer, you typically don't see this, right? The system crashing, the application crashing, and it's throwing error messages that only people who are programmers could understand. Yeah, we need to kind of like abstract this a little bit, or encapsulate this so that the end user experience doesn't suffer from this. So you basically, for instance, I always need to make sure, right, that the user enters integers, and if he doesn't enter integers, I need to say, okay, send a message that you haven't entered an integer, and continue with the rest of the program. Yeah? So really, we need to do something called catching exceptions. Yeah, we need to catch exceptions and deal with them appropriately. Let's see how. Questions so far? Okay. So what can go wrong with the above code? We said, right, you cannot convert the user input to integers, or B is 0, so division by 0. Okay, so dealing with exceptions, the mechanism that we have in Python and in most programming languages is to do what is called try except. Yeah, so called catching an exception. So we say the following, right? The keyword to use is try. Yeah, it's similar to if, else, right? But it's really used for exceptions. So I have the keyword try. Yeah, so I have this keyword try, okay? And it's basically, I put these statements that I want. So the part of my code that I want to, make sure that if an exception happens, I take care of it so that it doesn't stop execution and return these ugly error messages. So I indent this inside the body of the try. So I have 3 statements inside the body of the try for this code: reading A, reading B, and casting them into integers, and then printing A over B, so dividing A by B and printing that value. What will happen is, and now I'm saying except, so what is the except statement? If any of these statements fail in the try because of an error, an exception, stop executing the program, the rest of the program, or stop executing the rest of the statements inside the body of try and handle the except. Yeah, so if I try, to insert an integer, a value that is not an integer, it's going to stop and say non-integer or second is 0, right? If I insert 2 integers, but b happens to be 0, it's gonna get into the except statement. Otherwise, it's not gonna get into the except statement. So the accepts part happens only when, you know, right, this fails. Something failed here in the body of the try. Okay, let's try to run this and see what it gives us. Okay. Okie dokie. So I'm gonna take the code. So exception 1. Okay, so I did a whole exactly as in the slide, right? So try, you know, reading 2 integers, print the division, and then print non-integers or second 0 if one of these 3 statements fail. Doesn't matter which one. Let's run it. So I'm gonna start it with, you know, good input. So I'm gonna insert 1, and then 2, and it's going to print 0.5, and it's not gonna execute the accept statement because nothing went wrong in the 3 statements in the try. Let's try it again. Now I'm going to enter 1 and 0. What it's going to do, so it read A, it read B, it tries to compute A over B, that's 1 over 0, that's an error or an exception. So it's gonna stop executing and get into the accept and prints non-integer per second is 0. Yeah, let's run it again. Enter a number, I'm gonna say, you know, 1. So it's asked me for the second number, and I'm going to insert the string in that case. It will stop immediately and says non-integers per second is 0. Yeah, so this is really what the try and accept does. Questions about this? Is this difficult? Any questions? Okay. Can I admit Jad? Yes, I can admit Jad. Where is Jad? Sorry, Jad. Sorry, Jad, you've been here for a long time? Okay. Good. Yeah, I just looked at the Khaled, thank you. I just looked at the waiting room. There was only Jad, and I let him in. Okay? Good. So for Jad and the people who are, you know, a little bit late, what we're doing is we're dealing with exceptions, trying to catch exceptions. What are exceptions? Again, these are errors, you know, like, you know, try to cast a value that is not an integer into an integer, or you're trying to divide by 0 in this example. And how do I catch these exceptions so that the program doesn't stop execution, crashes, and send me this, you know, weird error message? Is to use the try except mechanism. Yeah, so you put, you know, all your statements inside the try block, like here in the slide, and then say what happens if something went wrong. What do I want to do? Here I just say stop executing, you know, whatever statements come next after the error, and print, you know, something friendly to the user that you have entered non-integers or second is 0. Okay, we'll see more examples on this. Ask me, Jad, if you have, you know, questions. I can also do separate except clauses to deal with particular type of exception. Yeah, so here in the previous slide, what we did is we combined all types of errors into one exception, yeah, into one, you know, except statement that prints non-integers or second is 0. How about separating them? I want to actually be very, you know, specific with the user. If he enters, you know, non-integers, I want to tell him you've entered non-integers. If he entered, you know, 2 integers but b was 0, I want to tell him that there was a division by 0. So let's see how to do this. I can have one try block, you know, and multiple except statements or clauses. So let's see how. I'm going to have 2 except clauses here in this exercise. The first one is value error, because I know that if I try to cast a non-integer into an integer, that throws a value error. So I'm going to say could not convert to integers. Okay, and then I'm going to add another except which says 0 division error, right? So if this, you know, the error that happened was a 0 division error, I'm telling the user that you cannot divide by 0. Okay, so I have 1 try body and 2 except statements. How is going to execute it? it's going to say, okay, check what type of error happens, if any. If it was a value error, so casting error, it's going to go into the first one and not the second one. And if it was division by 0, it's going to go into the second one and not the first one. I can even add a very general, except that says, you know what, right? Maybe I haven't thought of all the possible errors. Something went really wrong. And in this case, I can't think of anything other than these two types of errors. But in general, you can have, specific, except clauses for different types, and you can have one general that for any error it will, enter in there. Let's run this code. Let's see what it does. Everybody's here. Okay. Okay. I'm going to run it. Enter a number. If I enter S, can somebody tell me what will happen in this code? The code on the left. If I enter a number, so I executed the line 2, and then I put S as an input. Which part does it go into in this code? Any thoughts? First of all, it will have to stop executing the try, because I'm entering an integer, right? Non-integer. So where does it go? We've just said, right? I have 3 except statements. Which one it will get into, since it's not an integer? Could not convert, exactly, right? Name S is not defined. Okay. Let me see what happened here. Let me run it again, sorry. Right, enter a number, let's say S, right? So it's not a variable. Something is weird here. Give me a second. Not sure why it's not running correctly. Enter a number, let's see, do 0.5, maybe. Could not convert. Okay, so just it seems there's something weird with the interpreter. Yeah, so I entered, and instead of an integer, a float. It went into could not convert to integers. Let's run it again. Ask me to enter a number. Okay, let's try to enter 1 and then 0. What do you expect to happen in that case? If I enter A as 1, B as 0, both of them are integers. Which exception is going to get into? Zero division. Exactly. Could not divide by 0. Okay. Otherwise, it will execute normally. So if I run it with 2 valid values, 1, and let's say 5, it's going to just print 0.2. None of the exception statements are going to be executed. Okay. Questions? Very good. Okay, so sanity check. I'm going to ask you, read this program for a second, please, and then I'm going to ask you, I'll tell you A is this value, I entered this value, B, I entered this value. Tell me what is going to be printed on the screen. Okay, just have a look on it for 30 seconds, please. Okay, so if A is equal to 1, B is equal to 2. What is going to happen if I inserted, A equal to 1 and B equal to 2? What do you think is going to print? It's going to print, yes, 0.5. So far, so good, exactly. Then 0.5 or half, and then all good, and then done. Exactly, right? So it's going to skip the except because there was nothing, no errors. this program will run all of the try statements and then continue the rest of the program because nothing went wrong. Okay, let's do the following. Let's try to okay, now let's try A equal to 1, B equal to 0.3. What is it going to do? In that case, right, B was, I tried to cast B, which is a float, into an integer. That fails, yeah, because 0.3 is not an integer. I cannot cast it into a float, into an integer. Is it going to print so far so good? It's going to print immediately something went wrong, and then done, right? So for Grady, right, you said it's going to print so far so good. No, it's not going to print so far so good. It's going to, because it's going to fail at this statement. So it stops here, right? Executing the try block because it tries to cast the 0.3 into an integer. It fails, so it's going to skip all of this and get into the, accept statement, execute it, and then continue with the rest of the program. Yeah, so it's going to print something went wrong and then done. Okay. Let's try another example. So let's say I insert A equal to 1, B equal to 0. Why is it going to print? So far, so good. Excellent. And then something went wrong. And then, right? So it's going to do, it execute the statement correctly, both of them are integers. Then it will going to print so far, so good. And then it fails here when it's trying to compute A over B. That's where it fails. This would not be executed because it failed here. So it's going to go into the except, print something went wrong, and then continue with the rest of the program. Okay, that's really how it works. All right, very good. Questions? Okay, in this assignment, the coming up assignment, we ask you to kind of start doing these, try and accept mechanisms. And in general, for real code, you have to always do this, yeah, or in order for you to kind of have a well-established code or software that doesn't crash. And this is really the mechanism we always do when writing real programs. Okie dokie. Let's do another example. So we're going to assume the following. We're given a dictionary for this beautiful course, CMPS 200. What is a dictionary? It's a key value pair. Yeah? So it's almost like a list of key value pairs. Okay, key is the name of the student, and the value is a list of grades on the assignment. Remember, a dictionary, the keys can be any, data type that is immutable. So like, strings, tuples, integers, floats, and so on. And the values can be any data type. So here I have the key are names, strings, and the values are lists. So each one is a value. What is these values? It's your grades in the assignment. So Ali got 80 on the first assignment, 70 on the second assignment, and 85 on the third assignment. And Hoda got 100, 80, and 74. Okay, good. And we want to do the following. We want to create a new dictionary. So your program should, at the end, return a new dictionary, which has the name and the average. Yeah? So average of Ali on all the three assignments is 80, 70, and 85, added together, divided by 3. All right. So this is what I want to do. For Hoda, again, I sum her grades in all the assignments, divide by 3, that gives me Hoda's average. So let's see how I write this code. I'm gonna, have 2 functions. Yeah? So I'm gonna break it into 2 functions, and then, use these 2 functions to write my whole program, yeah, or to call my whole program. So let's see the 2 functions. Assume this is the input, right? Just for you to kind of have an imagination of what the input would look like, but that would be given by the user. Yeah. Okay, so I defined the first function, which is get stats. It takes, this class dictionary, which has names as keys and a list of values as value, a list of, grades as value. And this is the thing I'm going to return. Yeah, this is the one that I'm going to return. So it's an empty dictionary at the beginning, and I'm going to put in it for every name, what is the average of their grades. So here's how I did it, right? I said, okay, loop over this class dictionary. So, that would be the first item. That would be the second item, key and value together. And I'm going to say, insert in the stats dictionary, the name of the student, and, compute the average of his grades, the value, the average of class of dictionary of E. Yeah? So E is going to be a name, class dictionary is this guy. So when I give it class dictionary of Ali, it's going to give me this list, 80, 70, and 85. Okay, and I define this function average here as a function that just returns sum of the list divided by the length of the list. So it's going to sum 80 plus 70 plus 85 if I give it this list and divide by the length of this list, which is 3. That's all it does. And at the end, I just return this stats. Okay. What do you mean by 3, Mahdi? Okay. Yeah, maybe we're still discussing something that, the length of the list is 3. Yeah. Okay. Divide by 3. Yes, exactly. But here, right, I'm assuming, right, that in this example, it's 3, but it could be general, right? It could be that, I have 10 assignments, or somebody has submitted 9 assignments, some have submitted 5, and so on. So I want to make it general, Take the list of the grades, sum them, and divide by the length. In that case, yeah, for both of these students, it was 3, but in general, it could be more or less. Yeah, and it could be different from one student to the other. Okay, let's run this code first, and then we'll see what can go wrong and how I can deal with this using exceptions. All right, so let's see, where is that? Okay. So here's my code. Okay, I defined 2 functions. The get stats, as we said, right, and the average of grades, which take a list of grades and give me back the row. I'm going to say print get stats. Okay, so this method that return, for Ali, that's his average on the assignments, and for Hoda, this is the average on the assignments. Yeah, and I give it, the exact same values as in the slide. Let's run, and it gives me back Ali 78.333 and Hoda 84.666. Yeah, so it runs perfectly fine. Okay, good. Now let's see what could go wrong and how to deal with it. So here is what could happen. One particular error. If one or more students don't have any grades, we get an error, 0 division error. Yeah. Let's see why. Let's assume that the following, right? Ali, had 3 assignments, grades for 3 assignments, so that's grades for 3 assignments, but Alain, unfortunately, did not submit any assignment. So his list is empty. Okay. Now there is a method, right, in the previous slide, average of grades, that takes, the grade list, which is going to be for Alain, this empty list, right? So grades is this empty list, okay? And it's going to return sum of grades. Sum of an empty list is 0. What is length of grades? When grades is an empty list, what is the length of grades? If you do the length of an empty list, 0, right? So I'm going to return, 0, like something divided by 0, that's going to give me 0 division error. Okay, that's the 0. Exactly. Let's just test it first on our code, see if that is the case, and then we'll see how to deal with it. All right, so I'm going to assume that the 3rd student here, which is Alain, which happens to have not submitted a single assignment. Okay, I'm going to run. And as you see, 0 division error, division by 0. So this is really problematic. I mean, I have 2 students and I could have, 50 students or 100 students, all of them have submitted assignments, they have grades. And then one particular student who did not submit any assignment because he dropped the course and he's still on Moodle, and it screws up my program completely. My program doesn't do anything, basically. It just fails and it stops executing and doesn't work. I don't want this. I want to be able to say, okay, if you have a case where one or more students don't have any grades, just deal with it, and continue the program. Yeah. So don't crash, basically. So let's see how I can do this. One possible way, of course, I could do a check if the list is not greater than 0, do something. So I can always use an if statement, but I could also use the try catch mechanism, or try exception mechanism. Okay. So here's what I'm going to do. I'm going to define my function or change my function, the average function, which takes a list, to do the following. To try to execute this statement, right? Sum of grades divided by length of grades. And if that fails because of a 0 division error, so basically the grades is empty, then I'm going to print no grades. Okay? That's what I'm going to do. This this thing has to be, that quote is inside, not outside. This is the type. Yeah, this has to be here. Okay. So basically, I'm going to say the following: if for one student he has no grades, then just print no grades. Yeah. And for other students, you will run perfectly normal. Let's try this out. Yeah, so I'm going to do here, try. Right. Return some except, right, or except 0 division error, it's called, I think. Let me see. 0 division error, yes. I'm going to say print no grades. Let's try it out and see what happens. So again, I have to pick 2 students which have grades and Anna which doesn't have any grades. Let's see what will happen. And it did perfectly. It did much better, right? So it said for, it printed no grades because, I called it once with Alain. So the first time, right, I called it with Ali, the grades of Ali. It's going to compute the grade of Ali and insert it into the stats dictionary, okay? For Hoda, it was going to do the same. And then when it comes to Alain, it's going to do the try. It fails because the length of grades is 0. So it's going to print no grades. And then eventually, we'll insert for Alain, the name Alain here. And, what does this method return when it gets into the except? It returns none, right? It doesn't return anything. So it's going to return none. Yeah, that would be inserted in the dictionary with Alain. And then at the end, print, right, this guy. So print the whole stats thing. Okay? Do you understand the none? Where did the none come from? Can you explain to me why it put for Alain none? We got this method, right? When it comes to Alain, that's the third element. So the stats would have had 2 people, Ali and Hoda. And now when it comes to Alain, it's gonna not be able to compute, the average. So it's gonna get into the except. It's gonna print no grades. And then what does this method return in the case of the except? So when it doesn't return anything. I don't have a return statement in the except. Yeah? So it's going to return none. A method that doesn't return anything just returns none. So this average, right, of class dictionary of E, in the case of Alain, when Alain is the E, it's going to have to be equal to none. That's the value that it returns. Right? So I'm going to insert in the dictionary for Alain none. Okay. Good, but not great. Yeah, we want better than this. Yeah, so this is what we've seen on the, on the editor. How about the following? I'm going to modify it a little bit. So I'm going to say, return 0. In the case of the exception, instead of returning none, return 0. So explicitly, I'm adding, this statement inside the except. So if it works, you're going to return the average of the grades. If it fails, you're going to return 0 because, if you don't have any grades in the assignment or you haven't submitted any assignments, then your average should be 0. Okay, so let's try it. I'm going to add here return 0. Okay, and now if I run it, it should print for Anna the grade is 0. Okay. Questions? All right. Let's move on. Okay, one more thing so that you're able to do the assignment, and then we'll do one last exercise and that's it. So what are assertions, right? These are mechanisms similar to try and except that is usually used to handle errors, but this is called defensive programming. So you do it, right, inside any function, or not necessarily inside any function, you can write it anywhere in code, but usually we use it inside functions to, make sure that assumptions on the state of the computations are as expected. Yeah. So what happens is you write this assert statement, and if it fails, the program will going to throw an assertion error. Let's see an example. So I can modify my function grades, right, the average of grades, to add this assertion. So I add the keyword assert. So that's the keyword, right? It's a keyword similar to def, class, and so on, right? And then I say, okay, length of grades not equal to 0. So I'm asserting, or I'm making an assumption that this method, when it takes a list, its length is not equal to 0. Okay. So what happens is that each time you call this function with an argument with grades, some value of grades, it's going to check this assertion to see is really the length of grades not equal to 0. If yes, it continues with the method. If not, it's going to print this error, right, or throw this error to the caller. Yeah, so it throws an assertion error to the caller. Otherwise, it runs. Okay. Yeah, and function ends immediately if assertion not. Let's see, how we do this in the code. So I can, instead of doing try here, I can say assert. Let me copy it just for the sake of time. Yeah. Okay. Just to show you the difference between what we've done. Right, here it is. Okay, so I'm saying assert not, right, or length of grades not equal to 0. That's the same as saying not length of grades equal to 0 is the same as length of grades not equal to 0, of course. Yeah. If I run it, it gives me an assertion error, no grades. Yeah. So of course the program crashed, and it's not exactly the same as the try except, but you could always do this in the in your functions, what is called the defensive programming, so that you don't execute a function with the wrong argument. Yeah. And then handle or catch this assertion error in where it's called. Yeah. So here in this method, you can add a try except, right? So inside get stats, you add the try except block to handle an assertion. Yeah. Just different ways of dealing with errors, if you wish. Yeah. Assertion versus exception, or catching exceptions. Questions? Yeah, so we might ask you write in the exam or in the assignment to either catch exceptions, or deal with them, or to add assertions. Yeah, so or both. We could ask you for doing. Okay, just one last thing, to close the loop on this, that we have other clauses for handling exceptions. Typically, we don't use them much, but just know them, right? So we have an else. Basically, this is executed when the execution of the try body completes without no exceptions. So I can have here, something like, let's say this is a try, and then I have except here, and then I could have another statement after the except, which is else. If the try works well, I'll skip the except and go and execute the else. If the try fails, I get into the except and don't execute the else. Yeah. And then there is also finally, which gets executed always, right? After try, else, and except, close. Yeah. So this is really basically always executed. Yeah. Just know them. Okay, I can also raise my, a certain exception when sometimes, right? So I can always raise a value error and say, my own message. Yeah, and then this exception will get raised to the caller, and I can handle it this way. So let's see a final example. What's that? Is it better to use one or the other? It's typically better to use both of them, Michael, right? So you could do assertions on certain functions, and then you could catch these assertion errors in the caller code and deal with it. So do a try, you know, catch, yeah, like exception. Yeah, so you can do both in principle, but I personally use, most of the time I just use the try except, yeah, in most of the code, because that's what matters to me more than assertions, yeah. But just something that I wanted to show you that it's also possible in Python, okay? Just a mechanism that I want you to know. Okay, one final exercise. Let's say I want to write a function that does the following, right? It takes two lists, L1 and L2, both are of equal length, and both are of numbers, and returns a list containing L1 of I divided by L2 of I. In other words, it gives me the ratios of the elements. So if I give it the list, let's say L1 is 1, 2, and 3, and L2 is, you know, let's say 5, 6, 8, it's going to give me back 1 over 5, 2 over 6, and 3 over 8. That's what I wanted. And it's as simple as this. You know, assuming both of them had the same length and both of them are numbers. Yeah. So I'm going to do the following, you know, loop over all the elements in, you know, these two lists, right? So I took length of L1, I could take length of L2. They're exactly the same. I'm going to say, you know, there's a list, which is the ratios, the output list, you know, that's going to hold the ratios. I'm going to append L1 of index divided by L2 of index, where index starts from 0 all the way till length of L. Okay, L1 or L2. So basically, divide the element from the first list at this current position with the element from the second list at this current position. Now, what could go wrong? Two things, right? First of all, zero division error. Maybe L2 has an element that is equal to 0 somewhere, right? So that's gonna throw a zero division error. So in that case, I want to append, you know, not a number. Yeah. So there is a construct in Python which is not NaN, right? That represents not a number. Similar to infinity, right? We have math.infinity or minus infinity. That's a similar construct. Yeah. Because I want to say, you know, if I'm dividing by 0, that's not a number. Yeah? But I want to still continue the program. You know, if I have one or more element that is 0 in list 2, I don't want that program to crash. Okay. And here's a general exception that, you know, if, you know, I'm trying to execute this and something else happened wrong, I don't know exactly what type of error, I'm going to say that, you know, most likely this function was called with bad arguments, meaning, you know, either the lists are not the same, or, you know, maybe one list contains strings and the other numbers, and so on, and then return at the end ratios. Yeah. So I'm trying to, you know, catch exceptions, catch things that could go wrong in this code, and, you know, return the best possible answer I could get. Okay. So let's see what happened if I run this code. Mm-hmm. Okay. Okay, so I'm going to run it. Here I'm giving it two lists, right? 1, 2, 3, 1, 4. Let's say start first with good arguments. 1, 2, 3, 1, 4, 5. Yeah. Here I did the following, right? So this is what I'm saying, you know, similar to assertion. I raised an error, you know, a value error, which has this method get ratios called with bad arguments, and then I quote it where I'm calling this method. So if this error gets raised to the caller, I'm caching it, and then, you know, dealing with it in the caller. Okay, so let's run it. Which module? Yeah, it's probably this one. Okay. Let's see. No. Let's say this. Just to see if that's good. I don't know why it's not working. Give me a second. What module is not? Let's see. Okay. Maybe that one. I don't know what it's wrong with it. That's right. Okay. Get ratios. Okay, it takes two lists. I'm gonna write it from scratch. I don't know what's its problem. Right, and then I have ratios. It's an empty list. And then I'm looping for I in range of length of L2. Right, ratios dot append L of I divide L1 of I, sorry, divided by L2 of I. Right, what else? Return ratios. Let's just see the base code if it without any. And let's say print get ratio of two lists, 1, 3, 5, and 2, 4, and 7. Okay, let's run it. I don't know where it's wrong with it. Is it working? Okay. Okay, so something is weird here. We'll run this example quickly next time. Right? I could try to find another editor right now, but we have only 1 minute. Let me see. Let's see if that works. Okay, yeah, it worked, right? So here, right, if I have a good argument, so if I give it a good argument, like, for 5 and run it, it's going to give me 1 and 0.5 and 0.6, right? Divided 1 by 1, 2 by 4, that's 0.5, and 3 by 5 is 0.6. Now, if I give it, a 0 in the second list, that takes me to this exact, so 0 division error, and it's going to append, NaN instead of dividing 3 by 0. So here's what it gives me: 1, 0.5, and NaN. And if I give it, different lists, so this one has higher length than the other one, for instance, so they're not the same list, then same length, it's going to give me ratios could not be computed because lists are not well formed. So what happens is that it goes into this except statement. It throws this get ratios called with bad argument to the caller. So this one would be, the statement will not be executed, and it creates the except statement here. Okay. Try it out again, right, on your own, please, and we can discuss it if you have any questions next time. Okay. Then we'll talk on Wednesday. We're going to talk about complexity maybe for a day, lecture or two, starting Wednesday, unless you have any questions. Okay, guys, thank you.